Okay guys, this is the introduction to angles, and our essential questions that we need to answer throughout these notes are: how can angles be classified, and what are the various angle relationships? And a basic summary of these notes is that you're going to learn the definition of angles, and you're also going to learn how to classify angles and what are the different angle pair relationships. All right, let's go ahead and get into it. A ray is a part of a line. It has one endpoint and extends indefinitely in one direction. Rays are named by stating the endpoint first, then any other point on the ray. So that basically means we start here at A, and then we work our way to the end of the ray. So when you're naming this, make sure you start with A. So this will be ray AB with the arrow pointing to the right, or you can call it ray AC. Make sure you do not try to go backwards, like don't try to say BA or BC or CA or something like that. And definitely don't point the arrow in the other direction. So all of these are incorrect. Okay, if you choose a point on a line, that point determines exactly two rays called opposite rays. Opposite rays make a straight line and an angle that measures 180 degrees. Opposite rays are named by using their common endpoint. So if we're looking at this example here, we see that on one side, if we start from B, that's a ray called BA. You start from the endpoint, and we're saying that B is now the endpoint, and you go toward the other point. And even though this is facing the opposite direction, even though it's pointing in the opposite direction, make sure that your arrow is pointing to the right when you write it down, when you name it. And then the other side is BC. So again, you start with the endpoint and you just write the other point second. So there you go. These two are opposite rays. They share a common endpoint. An angle is formed by two non-collinear rays that have a common endpoint. The sides are rays and the common endpoint is the vertex. So that just means that this point that they have in common, so again, this side and this side both have B in common. That is called the vertex. There are three different ways that you can name an angle. The first thing you can do is you can use the vertex letter. So in this case, the vertex is B, so we would just call that angle B. That's one way. Another way is by using three letters, two letters that are on either of the sides and the vertex. So for this example, it would be A, B, C. You have to go in order, and when I say go in order, make sure the vertex is in the middle. You could also call it C, B, A. You just have to make sure that vertex is in the middle. So that's going to be angle A, B, C, or you could call it angle CBA. The last way is by using the number. I don't know if you noticed, but there's a 5 right here. So if you see a number that's in the corner of an angle, you can use that as well. So this would be called angle 5. So if you look in the vertex corner and you see a number, you can name it that way. Next, we have the interior and exterior of an angle. An angle divides a plane into three distinct parts. We have on the angle, we have the interior, so on the angle would be actually on the angle. Then we have the interior of the angle, which would be this part over here that I colored in green. And then we have the exterior of the angle, which would be this part that I colored in that maroon color. Don't forget, interior means inside, exterior means outside. Okay, next we're going to talk about how to measure an angle by using degrees. Angles are measured in degrees. For example, the measure of this angle over here, and that is angle B, is 55 degrees. Now don't get confused. This has a degree sign next to it. That's that little bitty circle. So this is not, we can't call this angle 55 just because there's a number in the corner. Since it has a degree symbol, that means this angle is 55 degrees in measurement. The way that you read this is by saying the measure of angle B equals 55 degrees. Notice the markings on the angles. So now we're looking at this example here. We see that we have angle NMP. Don't forget the vertex letter has to go in the middle of the other two letters. And as you can see, this is 25 degrees, and it has a little arc in there. Then we see the other angle, angle RMQ. And again, M is the vertex, so it goes between the R and the Q. This one's also 25 degrees, and it also has an arc. That just means these angles are congruent. That's what that squiggly equal sign kind of thing means. It's an equal sign with a squiggle over it. It means congruent. So again, that is the symbol for congruent. You can see it right there. In other words, they're the same size. So next we have how to classify angles. You have your straight angle, which is pretty much what it sounds like. It's just a straight line here, and it measures 180 degrees. Then we have your right angle, which is 90 degrees, and it looks like that. And then we have an acute angle, an acute little angle. So it's gonna be more narrow than a right angle. Don't forget it has to be less than 90, but it does have to be greater than 0 degrees. Lastly, we have an obtuse angle. Looks like this. And it has to be more than 90 degrees, but it cannot be a straight line, so it has to be less than 180 degrees also. Now let's talk about angle relationships. We have adjacent angles. Adjacent just means next to, so next to. And here's some examples. You can see these 4 examples are all angles that are touching, right? They all share a common ray. You see they all share this ray, this ray, this ray, and this ray. They all have a ray in common. That means they're adjacent. They also have a vertex in common. Right angles, they're formed by perpendicular lines. Here's the symbol for perpendicular. Y'all should remember that. And here are 2 examples. And don't forget they have that little square in the corner. All right, this one's new. It's called vertical angles. They're called vertical angles, but they might be horizontal. I'm not really sure why they're called vertical angles. However, a vertical angle is just made by an X. And then if you look on one side of the X and the other side, those 2 angles are called vertical angles. But again, it could also be on here and here, and those are horizontal. But anyways, just remember that vertical angles, either if they're here or here, those are equal. And then this angle and this angle are also equal. Now, complementary angles have to equal 90 degrees. That is the only rule. When you add them up, they have to equal 90. They can be adjacent and touching, or they don't have to be adjacent. They could be separate, but they have to equal 90 together. So we call that part plus part equals 90. Supplementary angles, on the other hand, they equal 180 degrees. So when you add them up, they should be like a straight line, basically. So they can be adjacent like this and share, a vertex and a common side, or they don't have to be adjacent. They can be separate, but as long as they add up to 180, that means that they are supplementary. This is part plus part equals 180. Angle bisector. You should already know bisector means half. Okay, so basically if you have an angle that's divided in equal parts, then you would say that the ray that divides it is bisecting that angle. So QP bisects angle RPS. And once it's bisected, it should be kind of obvious, but angle RPQ and angle QPS are equal because RPS was cut in half. And that's a part equals part. Don't forget bisects, you're going to say part equals part. Remember that from segments? It's the same thing with angles. Linear pair. So a linear pair is exactly what it sounds like. It's a pair of angles that creates a line. So it's 2 angles that make a line together. So you see this angle and this angle together make a line. Notice that they have to be adjacent. They have to be adjacent. Very important. They're just like supplementary, but the only difference is that unlike supplementary, linear pairs have to be adjacent. Very important. All right, lastly is the angle addition postulate, which is just like the segment addition postulate. Basically, it's just saying, if I take this angle right here, ABC, which I wrote right there, and then if I add it to angle CBD, which is this angle right here, if I add those 2 together, they have to equal ABD, which I wrote right there. And again, this is a part plus part equals whole, and that's pretty much it for angles.